Leonard Mlodinow, The Upright Thinkers, The Human Journey from Living in Trees to Understanding the Cosmos. Embark on an enlightening journey through the fascinating evolution of human thinking and scientific advancements in Leonard Mlodinow's The Upright Thinkers. With a keen focus on how human nature and inherent curiosity have driven our species to explore the unknown, this summary delves into the roots of scientific methods, the emergence of civilizations, and the development of various fields like mathematics, physics, and chemistry. Learn how humanity's need to understand the world laid the foundation for the theories, discoveries, and technologies that shape our lives today.
The evolution of scientific thinking. Human nature and curiosity drove the development of scientific methods and analysis over time. Innovations like the earliest communities and sharing knowledge led to early technologies such as irrigation systems, and eventually, the rise of occupations and schools. The division of labor enabled people to focus on one job each day, making everyday survival possible. With the innate curiosity of children and the advantages cohabitation provided, humans have been solving problems and creating new ideas since the beginning of our species. The evolution of writing and mathematics. The development of standardized writing and mathematics revolutionized human communication and paved the way for modern science. Mesopotamian pictorial scripts were the earliest recorded form of writing that allowed people to keep records of transactions and helped communities grow. Over time, writing evolved, and combinations of symbols were used to describe complex concepts in fields like geology and medicine. The use of mathematics to make simple calculations and predictions was also evident during this time. The Egyptians developed a way of measuring the surfaces of large areas, which was beneficial in forming property lines. These advancements, though significant, were limited in scope. It would take 2 millennia before Indian mathematicians discovered the standard system of addition, subtraction, division, and multiplication that made modern science possible. Overall, the evolution of writing and mathematics played a critical role in unlocking our ability to share knowledge effectively and systematically. Ancient Greeks, pioneers of modern science. The ancient Greeks made major scientific breakthroughs by questioning the common belief that the gods were responsible for natural phenomena and introducing a new form of rational thinking. They were among the first to study physics and conduct scientific experiments. Pythagoras analyzed musical instrument strings and developed a mathematical equation to explain the difference in pitch. Aristotle distinguished between natural and violent change and introduced the concept of force. These contributions played a vital role in the development of modern science. Galileo, Newton, and the birth of modern science. After 1450, a new breed of scientific thinkers started expanding old observations in bold and new ways. Galileo Galilei's precise experiments and abstract scientific mind paved the way for modern scientific methods. He designed experiments, gave his observations exact measurements, and used abstraction to expand and make predictions. Isaac Newton's success was the result of years of research and 100-hour work weeks. He conducted experiments using his own body and even stared into the sun once, which inspired him to continue his studies. These two thinkers were instrumental in the birth of modern science. The evolution of chemistry. Chemistry, once a craft, has grown to be a vital field of science. From the discovery of mummification to the failed alchemists' attempts to create gold, Paracelsus' innovative concepts, and Robert Boyle's application of scientific thinking, chemistry and its evolution has given birth to numerous developments. Antoine Lavoisier's experiments revealed that different elements can merge or repel each other depending on the conditions, and the release of oxygen in the heating of mercuric oxide was a groundbreaking discovery. Chemistry has come a long way to reach the prominent position it holds today. The evolution of biology. Biology didn't always have the advanced understanding that it has today. Many theories were once believed, such as spontaneous generation. This was suggested by Jan Baptist van Helmont in the 17th century, who believed that mice could emerge from a mixture of wheat grains and dirty underwear. However, Once the microscope was invented, scientists discovered the complexities of even small animals, changing their understanding of the animal world. Charles Darwin's The Origin of Species, published in 1859, was a major development in biology. Darwin's understanding of evolution came from observing species' competition and ability to adapt to their habitat. While it took him several years to make his observations, he also found that traits like random variation occurred purely by accident. Using a growing network of scientists and a new penny post mail program, he was able to integrate data and produce his theory of natural selection and random variation. The discovery of atoms. In the early 1900s, groundbreaking scientists took a closer look at the previously unknown world of atoms after realizing that matter was made up of atomic particles. Max Planck's research on radiation contradicted commonly held beliefs in the scientific community but eventually led to the discovery of atomic particles. Albert Einstein took Planck's ideas to the next level by finding proof for the existence of atoms through observing the movements of small particles like pollen dust. Einstein also elaborated on Planck's work on radiation by studying light energy and discovering particles called photons. These discoveries shattered the notion that all scientific secrets had been unlocked and led to a new era of scientific exploration. Pioneers of atomic world. Planck, Einstein, Thomson, Rutherford, and Bohr made significant contributions to understanding the atomic world. Thomson discovered the electron while Rutherford proposed that the atom consisted of a positively charged nucleus with free-floating electrons. Bohr improved the model, suggesting that electrons could lose or gain energy by jumping to outer orbits. Their work forms the basis of our current understanding of the atom. Quantum theory unleashed. Unraveling the practicality of the invisible world of atoms through the power of quantum theory. The world of atoms has always been a mystery for scientists. The question of how to measure something that is invisible has always been a challenge. In the early 1900s, German physicist Werner Heisenberg came up with a theoretical approach to physics that relied solely on measurable factors such as radiation frequencies. He reasoned that concepts like position or speed would be unobservable and therefore unmeasurable at the atomic level. Heisenberg's invention of spectral data gave scientists a whole new language to describe invisible information, enabling an array of possible values to describe every possible color emitted by an atom. While Heisenberg's methods were quite abstract and challenging to apply in the practical world, Austrian physicist Erwin Schrödinger developed a more understandable system for quantum physics that augmented the Newtonian notation, which people were familiar with. This made quantum theory more accessible and allowed other scientists and inventors to apply these principles to their work. Over time, this has resulted in various inventions that have revolutionized the world. With the help of quantum theory, we can now enjoy the usefulness of a microwave, a three-dimensional scan of our brain, and the power of fiber optic cables that connect us. The crucial thing to note is that quantum theory is not just a science of the future but the science of the present. Quantum theory has enabled us to unravel the practicality of the invisible world of atoms. Its capabilities of predicting results on both the atomic level and the observational level make it a valuable asset to the scientific community. Undoubtedly, quantum theory has been a real game-changer, giving us the means to make things that seemed impossible, possible.
The Upright Thinkers is a testament to the dynamic progress of human thinking and its impact on our understanding of the universe. From the early days of invention and cohabitation to the groundbreaking work of Greek philosophers, scientists like Newton and Einstein, and the evolution of quantum physics, deeply appreciate the power of human curiosity and ingenuity. Mlodinow's book offers not just a mere catalog of scientific discoveries but an insightful narrative that sincerely celebrates the human spirit of inquiry and innovation. Contemplate the march towards modern science, as well as the vital role that rational thought, scientific questions, and collaboration have played in our quest for unveiling the mysteries of life, forging a deeper connection between our past accomplishments and our present-day reality.